Hello everyone, I welcome you all in the next lecture of 12th class NCERT Mathematics. In this lecture, I'll discuss question number 1 and 2 of exercise 1.2. So let's get started. What the question says? Show that the function f from r star to r star, focus on notation, fx is defined as 1 upon x is 1 1 as well as on 2. We need to show. Okay, and what is r star? R star is the set of all non-zero real numbers. Okay, and the first part is we need to prove on this domain and codomain the function is 1 1 on 2, that is bijective, and they are saying is this result, that is function is 1 1 on 2 on the domain if domain r star is replaced by the n. Okay, and codomain is remain same, we need to check. Okay, so the first part I will explain. What it says that the function is defined from r star to r star. Okay, and how they define the function? F of x equals to 1 upon x. We need to prove that the function is 1 1 on 2. What we need to prove? The function is to prove, we need to prove f is 1 1 and on 2. We need to prove. Okay, now for 1 1, for 1 1, let x1 comma x2 belongs to r star. With we need to assume one more thing also. What we need to assume? And f of x1 equal to f of x2. So if f of x1 equal to f of x2, then what it implies according to definition? 1 upon x1 equal to 1 upon x2. As x1 and x2 belongs to r star, so it means x1 and x2 both are non-zero real number. So hence from here x1 equal to x2 by cross multiplication. If we have this thing, it implies that f is 1 1 on r star. Okay, to r star. The function is 1 1. Now for on to we need to prove. For on to what we need to prove? Let y belongs to r star. Let y belongs to r star. F of x equals to y. Okay, so f of x equal to y, and this is belongs to codomain. Okay, codomain, the right side of the function very defined. F of x equal to y, it is 1 upon x equal to y, so the value of x is 1 upon y. It means that what it implies that for every y belongs to r star in codomain, we have x belongs to r star in domain of the form x equal to 1 upon y, we have f of x equal to y. Okay, and hence the function is onto, implies f is onto here, and if f is onto, it implies that f is 1 1 and onto. Hence proof the first part is complete. Okay, now how they define the second part? See here, they are saying that if we remove this domain set by this set of natural number, and this codomain is remain same, and function is like that, then we need to check is it 1 1 onto or not. Okay, what they are saying? The function, second part, function is defined from the set of natural number to a set of r star. Okay, f of x equals to 1 upon x. Check f is 1 1 and on to or not. Okay, now how we can check? See here, 411 411. Let x1 x2 belongs to natural number with f of x1 equal to f of x2 with f of x1 equal to f of x2. It is 1 upon x1 equal to 1 upon x2 implies x1 equal to x2, and hence it implies f is 1 1. Clear? But you can observe that here it is 1 1 and range of f contain elements like 1 1 by 2 1 by 3 up to so on. Okay, now for on to, okay, for on to let y equals to pi. Okay, let y equals to pi and we have f of x equals to y for some x. This thing I assume. Okay, for some x belongs to natural number. So 1 upon x equals to pi. So x value is 1 upon pi. But observe that x, but observe that what we need to observe, 1 upon pi does not belong to set of natural number. So it means that here y equals to pi in, which is in codomain set, y equals to pi which is in codomain set, codomain set does not have preimage, does not have preimage. It implies that range of f, it implies range of f not equal to codomain of f, implies f is not onto. Okay, so understand, by changing the domain what will happen, the onto is not preserved, the onto is not preserved. I hope you understand this question. Now the next question, check the injectivity and surjectivity of the following function. Okay, the first function is defined from the set of natural number to a set of natural number, and f of x they define as x square. Okay, now how we can check function 1 1 and ontoness? See, 4 1 1 4 1 1. According to definition we can go, let x1 comma x2 belongs to set of natural number. Okay, let x1 comma x2 belongs to natural number with, we need to assume that f of x1 equal to f of x2. Okay, if f of x1 equal to f of x2, it means that x1 square and x2 square both are same, and it means that x1 square minus x2 square equal to 0, and hence x1 minus x2 and x1 plus x2 equal to 0. Okay, and from here either this part is 0 or this part is 0. If this part is 0, then x1 equal to x2 we have, and if this one part is 0, x1 equal to minus x2, which is not possible because as x1 comma x2 belongs to natural number. Okay, so only this part is true. It implies that it implies that f is 1 1 function. F is 1 1 function. Okay, but observe that for onto okay, for onto let y equal to 2 we can choose. Let y equal to 2, let y equal to 2 belongs to set of natural number, that is codomain. Okay, now and assume that f of x equals to 2 for some x. Actually here I am giving counter examples. For some x belongs to natural number, it is x square equals to 2, so the x value is plus minus root 2, because of is a quality equation, so we get two values. But none of the value does not belong to natural number. It implies that y equal to 2 does not belongs to range of f, but y equal to 2 belongs to codomain of f. Okay, implies that range of f not equals to codomain of f, implies that f is not onto. Done? I have been listened. Next thing what we have, function defined from z to z, and same thing we have. Okay, next question is function defined from z to z and how they define f of x equal to x square. Clearly for 1 1 you can assume x1 equals to 1 and x2 equal to minus 1. x1 equal to 1 and x2 equals to minus 1. f of 1 is 1, f of minus 1 is 1, implies that different element have same image, implies that different element of domain have same image in codomain. What will happen? Implies that f is not 1 1. And for onto, clearly range of f is 0 plus minus 0 1 4 9 16 up to so on. These elements are there, so it implies that if only these elements are there, it implies that range of f not equal to codomain, that is z, hence f is not onto. Okay, next one is a function defined from R to R. The third part is function is defined from set R to set R, and how they define same. F of x equal to x square we have. Okay, same thing we have here. For 1 1, same our method. For 1 1, let, can I change, let x1 equal to minus 2, x2 equals to 2. F of minus 2 for f of 2 for, what we can say here, different element of domain set, different element of domain set. What we have, different element of domain set have same image, have same image, and the function is not 1 1. Okay, similarly for onto, what we can say, for onto what we have, as the function is x square which is greater than equal to 0, it implies that the range of f will be, what the range of f will be, close 0 to infinity. Okay, actually it is a like that, graph of this function is like that. Okay, so it implies that range of f is not equal to complete R. Why so? Because the negative element does not have preimage. Negative element are not in the range. It implies that f is not onto. Done? Okay. Now the next one is, what we have here, the fourth one. Function is defined from the set of natural number to a set of natural number. Okay, and how they define the function, f of x equal to x cube. Okay, now you can see that for 1 1, let x1 x2 belongs to n and f of x1 equal to f of x2. Okay, what we have, x1 cube, x2 cube, x1 cube minus x2 cube equal to 0. It implies that x1 minus x2. Okay, and what we have, x1 square plus x2 square plus x1 x2 equal to 0. Okay, now you can see this part is not equal to 0. Why so? Because see, x1 and x2 both are natural number. Okay, so x1 square is positive, x2 square is positive, x1 into x2 is also positive. Okay, so this complete quantity is positive quantity which is not equal to 0. It implies that x1 equal to x2. This has to be equal to 0, and if this is 0, then x1 equal to x2. Implies that f is 1 1 function. F is 1 1 function. Done. Now for onto, what we have for onto? For onto we have, see the range we can see here, range of f will be like natural number, na? Okay, 1 cube 1, 2 cube, 3 cube, 4 cube to so on. It means what type of element? 1, 8, 27, 64 to so on. Observe 3, many more actually, 2, 3, 4, 5, 6, 7. All these element does not have preimage. It implies range of f not equal to codomain set implies f is not onto. Okay, so I hope you understand. The fifth part is your homework. You need to do like that which I did before that. Okay, I hope you understand. If you have any doubt, then you can do comments. I will reply there. Okay, and try to resolve your query. Thank you for watching.